So, mm, basic stats. Probability is also very important thing for for machine learning or else data analytics. So theoretical probability. So we'll go example, a definition, and some examples. Okay. So here the probability is nothing but it's a topic in statistics that describe that likelihood of certain events happening. Okay. So for example, when you do one particular experiment, from that one we need to pick up one likelihood, okay, probability. So that kind of things we can do with the help of the probability. Okay, likelihood of certain events happening. When we talk about probability, we are often referring to one of the two types actually. So basically there is a two type of probabilities are there. One is the theoretical probability and second one is the experimental probability. Theoretical probability in the sense we are not doing any kind of experiment from our domain. Okay, you are giving some kind of assumptions and that kind of things. We are calling it say theoretical probability. The theoretical probability is the likelihood that an event will happen. The event will happen based on the pure mathematics. Okay, so we are talking the probability what will happen in the sense we are talking about future, right? Okay. For example, what could be the in just 1 second. So the formula to calculate the theoretical probability of event A happening. Okay, the representation is P of A, number of desired, this is the formula, number of desired outcomes by total number of possible outcomes. So with help of this formula we can calculate the probability, right? For example, the probability that a die land on the two after one roll can be calculated. Okay, so only one way to die can land on 2 by 6 possible, right? So 1 by 6 is the probability. So this is the theoretical probability. When coming to the experimental probability, it is actual probability of event occurring that you are directly observed in an experiment. When you do some kind of experiment, from that particular experiment you do some kind of observation, right? From that one we are doing the probability. Okay, number of times event occurred by total number of trials you did it. Okay, for example, suppose we roll a die 11 times and it land on 2 3 times. The exponent probability of die landing on 2 can be calculated. That means how many times the 3 is landed, 2 is landed, 3, right? So 3 by how many times you roll the die? So 11, right? So 3 by 11. So this is the probability of the event occurred 2. Okay, how to remember this difference is, we can remember the difference between the theoretical probability and experiment probability using following tricks. The theoretical probability of event occurring can be calculated in the theory using maths, but here the event occur can be calculated directly observing the result on experiment. Okay, so the benefits of using the theoretical probability is, we don't need to waste much time actually. Okay, statisticians often look to calculate a theoretical probability of event because it much easier and faster to calculate it the compared to actual conducting experiment. When if you want to do some kind of experiment, it might be take some time, it might be take some kind of time, right? Okay, so that theoretical probability, it could be little bit faster when you comparing the experimental probability. For example, suppose it's known that 1 out of every 30 students at a particular school will need additional help with their maths homework after the school. So instead of waiting to see how many students show off the homework help after the school administration could instead calculate the total number of students at the school, suppose 300, and multiply by the theoretical probability 1 by 30, right? So this is your 1 by 1, 1 out of the 30 students. This is your theoretical probability. So total number of students, how many? There are 300, right? So 1 by 30 into 300, then that means 10, right? To know that he is likely need 10 people present to help each of the student to one on one. That's a way we can calculate it. So example of theoretical probability, for example, a bag contains the following red balls and a green balls and 2 purple balls. Okay, here the question is, if you close your eyes and randomly pull out of one ball, what is the probability that will be the green? So how many green balls are there? 4, right? So how many total balls are there? 9, right? So 4 by 9 is your result. So you know, 9-sided dice that contains the numbers are 1 to 9. So if we have that, what is the probability of die land on 7 if you roll the one time? So 7 can be possible outcome is only 1, right? So 1 by 9. So this is the probability of getting the 7. Okay, then example 3 is a bag name, the bag contains the name of 3 boys, okay, 7 girls. So here the question is, if you close your eyes and randomly pull one name out of the bag, what is the probability of pull out of girl the name? So here total number of girls are the 7, right? 7 by 10. So 7 by 10 is the probability of the girl name, getting the girl name. Okay, so this is the intro about theoretical probability and experimental probability. Nothing much more, guys. Let's go for posterior probability. And so posterior probability is updated probability of some events occurring after counting of new information. So this is very important question or formula, guys. Based on this one, different machine learning algorithms also can be helpful for us. Okay, for example, we might you might need to be interested to finding the probability of some event occurring A occurring after we account of some events B that has been occurred. We could calculated the this posterior probability by using formula. See, A given B, this is the meaning is A given B. So if you want to finding the probability, okay, it might be depending on the B. So right, so that's the reason. So I want to be finding the probability of A after accounting of some events of the B. Okay, that means A given B equal to, so you know that probability of A and the probability of B given A and by probability of B. Okay, so here the probability of event occurring given that B occurred. Note that given. So this is the dots, this is the dollar, this is the pipe symbol, means that it's a given symbol. Okay, P of A, the probability that event occur. P of B in the sense the probability that event B occurred. Okay, probability of B given A, the probability of B occurring given that given that event A has been occurred. Okay, so there is some kind of example here. A forest is composed of 20% of the oak trees and 80% of the maple trees. Okay, the forest is composed with 20% of oak trees and 80% of the maple trees. Suppose it is known that 90% of the oak trees are healthy. Okay, so basically total, for example, if we have the 100 trees are there, out of the 100, 200 trees are the oak trees and 80 trees are the, okay, and so this maple trees, out of that, out of the 200, 90% out of the 200 trees, 90%, 90% means approximately 180 trees. Okay, 180 trees healthy, while just 50% of the maple trees are healthy. Okay, so if 80% in the sense, it's a 1800, right? Out of the 1800, 900 of maple trees are healthy. Because of that one, 90%, 180 of trees could be healthy for oak. Okay, suppose that from a distance you can tell that particular tree is healthy. What is the probability that the tree is an what is the probability that the tree is an oak tree? Okay, recall the probability of event occurring given that B has been occurred. So this means this is the formula. So in this example, the probability of the tree, right? The probability that the tree is an oak is given the tree is healthy. So probability of oak into probability of health given by oak by, okay, and probability of healthy. So here the probability that given the tree is 20% of the trees, right? Out the forest which consisting only 20% of the oak trees are there, right? That means 0.2% of the trees. So what is the healthy of trees? 90%, right? 0.2 into 0.9 plus, and so 0.8 in the sense the maple trees. So maple trees, and from that one only 50%, right? So that it's a 0.5. So this is the probability of the healthy, total healthy trees in the forest. 0.58 trees are only healthy. Okay, and now probability of healthy given by hook, the probability that probability that tree is healthy given that is an oak is the tree is 0.9. 90% of the trees healthy, right? Oak trees. Okay, so that 0.9 is the probability. So you know that this is the probability of the oak, and this is the probability health given oak, and this is the probability of total health. So now you can calculate it the what could be the healthy trees, what could be the healthy trees, what is the probability of the oak given healthy trees. Okay, so now you can substitute these values into this particular formula. You will be getting this value, you will be getting this value 0.313. So which means that for an intuition understanding of the probability, suppose that following the grid representing the forest with 100 trees, exactly 20 trees are the oak trees, and out of that one 80 trees are the healthy, the other 80 trees are the maple, out of that one 40 trees are the healthy. Okay, so O means it's oak, M means it's maple, green means it's healthy, red means unhealthy. Okay, so this is the way we can represent it. So out of all the trees, exactly 58 of the healthy trees and 18 of the healthy and oak, and the rest of the things 40 might from the maple. So total 58 trees are healthy. Okay, those we know that we selected healthy trees, then the probability oak tree is 18 by 58. 18 by 58. Okay, so 0.1318. So when we should use the posterior probability? The posterior probability is used in wide variety of domain, include in finance, in medicine, in economics, and weather forecasting. Okay, this kind of situations, this posterior probability will help you a lot. Okay, the whole point of using the posterior probability is an up-to-date previous behalf we had about something once we obtain the new information. Okay, so you might have some kind of previous information, might you will be getting the some new information because of the some kind of previous information. Okay, recall in the previous example that we knew the probability of given trees in the forest being whole was 20%. This is known as the prior probability. Okay, this is your prior probability. If you simply pick a tree at random, we know that the probability of its being an okay 22 0.2 probability only. Okay, however, once we obtained the new information that the tree we selected was healthy, we are able to use this new information to determine that the posterior probability of the tree being was it was 0.3. Okay, so you are able to go for finding the healthy tree could be it's a 0.3 probability out of the 100% of the probability. Okay, so this is the simple thing. This is very very important concept, posterior probability. And guys, I just want to give you much time for understanding of these two things, because of these two things are much important: theoretical probability and posterior probability. Okay, and you can go through this statology and go through these two articles and learn some information and come for the next class. Okay, but tomorrow we would like to complete these 4 points. If you want to understand these 4 points, make sure that we need to complete these two concepts. If and only if you have a good knowledge on these two, then only you will able to understand this four top points actually. Okay, clear?
Clear, sir.
Yes,
Yep, that's for today's session, and go and learn this statology, and we'll catch up by tomorrow for continuation of the probability concepts. Bye.
sir, recordings are 20.
Sure.